Hey space enthusiasts, welcome back to Space News. Today we're uncovering one of the universe's biggest mysteries. Why do black holes, the ultimate space giants, fade away over time? Stick around as we unravel the science behind their slow disappearance. And don't forget to smash that subscribe button to join our cosmic journey. Let's dive in. Let's kick things off with the basics. What exactly is a black hole? Imagine a star so massive that when it runs out of fuel, it collapses in on itself, creating a region of space where gravity is so intense that nothing, not even light, can escape. These cosmic monsters are like vacuum cleaners in the universe, pulling in everything that gets too close. But here's the twist: black holes aren't just voids. They're packed with matter crushed into an infinitely small point, known as a singularity. Surrounding it is the event horizon, the point of no return. If you cross it, there's no coming back. So, how can something so powerful eventually fade away? Let's explore. Black holes form from the dramatic deaths of massive stars. When a star burns through all its nuclear fuel, it can no longer resist the pull of its own gravity. The result? A supernova explosion followed by the birth of a black hole. Think about it, a single teaspoon of black hole material would weigh billions of tons. Their incredible gravity makes them one of the most mysterious phenomena in the universe. But wait, did you know not all black holes are the same? We have stellar mass black holes, formed from stars, and supermassive black holes, which sit at the centers of galaxies like our Milky Way. These supermassive giants can be millions or even billions of times heavier than our sun. But even they aren't immune to the process we're about to discuss: Hawking radiation. Now here's where the science gets truly fascinating. In the 1970s, physicist Stephen Hawking proposed something groundbreaking. Black holes aren't eternal, they can slowly lose energy through a process called Hawking radiation. Here's how it works. Near the event horizon, pairs of particles and antiparticles spontaneously pop into existence. Normally, these pairs annihilate each other in an instant. But when this happens near a black hole, one particle might get pulled in, while the other escapes into space. This escaping particle carries energy away, causing the black hole to lose a tiny bit of mass. Over time, think billions or trillions of years, this process causes the black hole to shrink and eventually disappear. It's like a cosmic leak. But there's more to the story, so let's keep going. As the black hole continues to lose mass, something fascinating happens. It heats up. The smaller it gets, the hotter it becomes, radiating more energy. This creates a feedback loop. The more it radiates, the faster it shrinks. Picture this. A black hole the size of a star will take far longer to evaporate than the current age of the universe. But near the end of its life, the process speeds up dramatically. The black hole grows so hot that it emits a burst of energy, like a final cosmic fireworks display before fading into nothingness. But here's the ultimate question: what happens when a black hole is gone? When it emits its final burst of radiation, all that's left is pure energy. No singularity, no event horizon, just the faint echoes of its existence in the fabric of space-time. Some scientists theorize that this could provide clues about the origins of our universe. Could the death of one black hole seed the birth of another? Could this energy hold the secrets to understanding dark matter or the nature of gravity? The possibilities are as endless as the universe itself. And there you have it, the incredible journey of a black hole from its formation to its dramatic disappearance. If this blew your mind, don't forget to like, comment, and subscribe. There's so much more to explore in the vast cosmos, and we're just getting started. See you in the next adventure, space explorers.